Alrighty, in today's video, we're going to be talking about 7.1 exponential functions and their graphs. All right, in this one, an exponential function pretty much just looks like anything with a power of x as the exponent. Instead of it just being a number, now it's a letter. And you have two types of exponential functions. You have an increasing function and a decreasing function. They're like half of a rational function, but this would be what an increasing function would look like. And a decreasing function would look like this right here. So it's only one branch in an exponential function versus rational functions, but that's pretty much what your two cases are, increasing or decreasing. And then pretty much that is pretty much it. And then it gets into some solving. But things to kind of pay attention to is it is a decreasing function. If the a is less than 1 but greater than 0, and it's increasing function if it's greater than 1. So if it's like half, you're halving your stuff, so it's going to be decreasing. And if it's like 3, you're tripling your stuff, so it's going to be increasing. So you can think of it like that. All right, and that, again, that's pretty much it. And then it gets into some solving skills, but I'm going to go over those when we get into some of those questions. So let's look at our first set of questions on page 455. This is going to be question 2. We're going to sketch the graph of the following functions. So we have g of x equals 0.5x. Oh, x in the wrong location. So this right here, your first point is going to be at 0, 1. That's your starting point, and then it's a decreasing function, so it'll look like this. And that's pretty much it. Number 3 gets a little bit more. So this is f of x equals, not 3, sorry, 4. So this is going to be 1/3 x plus 1. So the plus 1 there is going to shift this point over, but this pretty much does the opposite of what you want. So if it's, you'll go left if it's positive, and you'll go right if it's negative. So in this case, so this is what this point will do. So instead of crossing here, I'll actually cross left 1. This is still a decreasing function. So now my function looks like this instead. So pretty much the same. Just this right here controls your left and right movement. If I would have added or subtracted things on the outside here, I would move it uh, up and down. Sorry, up and down. All right, let's look at some more different type of graphs you'll have to graph. So let's look at number 19. 19 says r of x equals 9/2 to the negative x. All right, you don't know how to graph a negative. So recall that I can flip the fraction inside and make the exponent positive from when we're solving these functions with logarithms. All right, so with that, that now means that my graph is now a decreasing, and it didn't shift, so it'll be right here. So this is a decreasing function now. And I completely missed that question. I didn't realize it told me to state the domain range. So domain here is going to be all real numbers. The range is going to be from 0 on to infinity, because that's as low as the range can get. And this is all pretty much the same stuff. It's not always that case, but for right now, it's all that we've seen. Let's look at number 21. 21 is r of x equals 1 minus 15/4 to the power of x. So this one's going to shift it left and right, I mean up and down. So what happens is originally I'm right here, and now I'm going to go up 1. So now it's right here. And then there's a negative on the outside. So when there's a negative on the outside, it's going to flip it across the x-axis. So now I have it right here. And so instead of the function going like this, when it flips it, it's now going to kind of go like this. Okay, hold on. Let me kind of show this one more time. So that's where that point will be, yes. But there's technically also something that's being moved around. There's technically a horizontal asymptote right here. And then now there's an asymptote right here because it gets shifted. So the new one, do it in blue, will be right here because it went up 1. So now instead of it kind of going like this, it now flips over this. And so you get something that looks like this. Ooh, like that. So take these points away. I forgot that they do this. So this point would have gone here, up 1, but so did the horizontal asymptote. So then it would have looked like this because it's an increasing function. But then that negative reflects across that new horizontal asymptote. So now from here, the point goes to this one, not all the way over here. So it only goes across the horizontal asymptote, and then it kind of goes like this. And so now your domain is still all real numbers, but now your range is -infinity to 1. All right. So it's a good one to look at. So then the rest of these questions are now just solving. So we'll talk about how to solve these different types. So let's look at number 22. Let's say we have 5x equals 125. The goal here is to have the same bases. So if your base is 5 here, try to figure out how I can make this base of 5. So we know 5 times 5 is 25, times another 5 would give me 125. So that would mean 1, 2, 3, 5 to the third power would be 125. Well, if these two things are equal, then this right here must be equal. So the answer here would be just x equals 3. Then look at number 26. 26 is 4 to the power of negative x equals 16. Remember, we can't solve exponents, so I'm just going to flip the fraction. So now this is 1/4 to the power of x equals 16. So now the question is, how do I make this look like this? So if I was to change this to a -1, I would now have 1/16. And then we now know that 4 squared would be 16. So this would be the same thing as 1 to the 4th squared raised to the -1. So right, that give me 1/16, and that would give me back up there. So that means a power to a power, I would multiply. So now I get 1/4 to the -2 is equal to 1/4 to the x. So again, these two things must be equal. So I get -2 as my x. All right. So it's kind of manipulating the other side to get your answers, pretty much what this game is. Let's look at 29. 29 is 2 divided by 3 raised to the x plus 3 equals 9/4 raised to the -x. All right, so again, this is pretty close. This one I think I can manipulate. If I flip this, so that's 4/9, this is now a positive x. And then this looks a lot like 2 cubed squared to the power of x, because that would give me 4 and 9. So that means this would be 2/3. 2 times x is 2x. And this would be 2/3 x plus 3. So then I can set these two equal. So x plus 3 equals 2x. Subtract x, subtract x. So I get 3 equals x. That's my answer. All right, so this is like a manipulation game here. Let's look at 31. You get 4 raised to the power of 3x plus 2 equals to 1/4 to the power of negative 2x. I want this to also be a 4. So I think I'll make this 4, and then I can just change the sign to a positive 2x. So now these two are equal. So I now get 3x plus 2 equals 2x. I'm going to subtract 2x on both sides. This will give me x plus 2, so therefore x equals negative 2 as my answer. Again, the key to this is just seeing a pattern on how you can manipulate it. So let's look at 34. We get 3 to the power of x squared plus 4x equals 81 to the negative 1. All right, this one, I'm pretty sure this will work. 3 times 3 is 9, times 3 is 27, times 3 is 81. So that's 1, 2, 3, 4. So this is 3x squared plus 4x equals 3 to the 4th power raised to the negative 1. So that'd be 3 to the negative 4. So then these would be equal. So x squared plus 4x equals negative 4. I'm going to add 4. So I get x squared plus 4x plus 4 equals 0. And that would be x plus 2 twice. So that means x equals negative 2. I don't have to write it twice. It'll be one time. There you go. Let's do one more, and I think I mean, again, the goal is just to see patterns. So I think I will have shown every pattern that you would need on the homework. So 43 is 1,000 raised to the negative x equals 10 to the power of x minus 8. So this is 10. I want to try to make this 10. So that'd be 10 times 100 times another 10. So that'd be 10 cubed raised to the negative x, a power to a power. You multiply. So this is 10 to the negative 3x would equal 10 to the x minus 8. These must be then equal. So negative 3x equals x minus 8. So I'm going to add 3x, try to avoid the negatives if I can. So I get 0 equals 4x minus 8. Add the 8. So then I get 8 equals 4x, divide that by 4. So I get x equals 2. All right, that's, like I said, pretty much everything you're going to see on your homework. The goal there is just to kind of see patterns. But other than that, that is all that I got for you. If you need more examples or guidance, just let me know. Other than that, I'll see you in the next video. Bye for now.